About 2 billion people around the world suffer from deficiencies of key micronutrients such as iron and vitamin A. 2 million children die from these deficiencies every year, and people who don't get enough of these nutrients can develop blindness, anemia, and cognitive impairments. MIT researchers have now developed a new way to fortify staple foods with these micronutrients by encapsulating them in a biocompatible polymer that prevents the nutrients from being degraded during storage or cooking. In a small clinical trial, they showed that women who ate bread fortified with encapsulated iron were able to absorb iron from the food. The researchers now hope to run clinical trials in developing nations where micronutrient deficiencies are common. Lack of vitamin A is the world's leading cause of preventable blindness, and it can also impair immunity, making children more susceptible to diseases such as measles. Iron deficiency can lead to anemia and also impairs cognitive development in children, contributing to a cycle of poverty. These children don't do well in school because of their poor health, and when they grow up, they may have difficulties finding a job. So, their kids are also living in poverty and often without access to education. The MIT team set out to develop new technology that could help with efforts to fortify foods with essential micronutrients. Fortification has proven successful in the past with the iodized salt and offers a way to incorporate nutrients in a way that doesn't require people to change their eating habits. However, simply adding vitamin A or iron to foods doesn't work well. Vitamin A is very sensitive to heat and can be degraded during cooking, and iron can bind to other molecules in food, giving the food a metallic taste. To overcome that, the MIT team set out to find a way to encapsulate micronutrients in a material that would protect them from being broken down or interacting with other molecules, and then release them after being consumed. The researchers tested about 50 different polymers and settled on one known as BMC. This polymer is currently used in dietary supplements, and in the United States it is classified as generally regarded as safe. Using this polymer, the researchers showed that they could encapsulate 11 different micronutrients, including zinc, vitamin B2, niacin, biotin, and vitamin C, as well as iron and vitamin A. They also demonstrated that they could encapsulate combinations of up to 4 of the micronutrients together. Tests in the lab showed that the encapsulated micronutrients were unharmed after being boiled for 2 hours. The encapsulation also protected nutrients from ultraviolet light and from oxidizing chemicals such as polyphenols found in fruits and vegetables when the particles were exposed to very acidic conditions, that is around 1.5 pH, typical of the pH in the stomach. The polymer becomes soluble and the micronutrients were released.